Um, we are Group 39. I'm Chaitanya. With me is Babu, Vijay, Harishankar, and we have developed a platform using geospatial and transfer learning techniques. We've merged Yelp data along with American Community Survey data, and this platform can help in planning economic development activities. Of course, we focused on the ability of restaurants to act as agents of economic development. In this checkpoint, we're going to talk about how we implemented the ML pipeline. We looked specifically at opportunities for economic growth. And we not only found that the American survey data was helpful in this regard, but we also found in Ohio very specific data on food deserts by zip code. And we learned that we not only need to look at data at the level of the census tract, but also aggregated data at the level of zip code. And by locating a restaurant and combining these layers, we are able to tag each restaurant with zip code level data as well as census tract level data, thereby working on models that can demonstrate the impact a particular food establishment may have on the local community. So, what we've done here is looked at this ML pipeline that brought together two different geospatial layers, combined them together, brought data in from Yelp, tagged the geospatial data with the restaurant data, and then ran a number of models based on reviews, rating, and sentiment analysis to get some idea as to the implication of that restaurant being located there. So, the outline for the presentation, we'll discuss the data sources, we'll discuss how we prepared the data. We will then go through some very quickly the EDA data visualization and key research questions that we asked ourselves. We will then run through some of the models that we developed. These models may have been only run on a subset of data due to limitations of time, and then our plans for improved methods and application of transfer learning. The ML pipeline was particularly challenging because of the spatial joins. We had to pull the data in as a shapefile, take that shapefile, merge it with the ACS data, and then separately pull in another shapefile for zip codes, merge that data file with ranking data uh, by each zip code, and then pull in the Yelp data file and convert that data file also into a geodata frame, export all of that into a GeoJSON, and then finally map that data. So this was very challenging. But what the geospatial joins allowed us to do was to then create subsets of the data by zip code, by restaurant type. So we had geotagged informations to feed our models. However, in this checkpoint, we have generated the maps, we have run the models, and in our final improvement, we will take the geotagged models, once again run our models to show how geotagged information can have better prediction than the current non-geotagged models. Um, the EDA we'll run through very quickly. We looked at the businesses, we looked at the ratings, we looked at the number of different kind of businesses, and then we focused specifically on the restaurant businesses. This here shows you, we also looked at comparison across cities. So while our focus was comparison between census tracts and between zip codes and merging census tract data with zip codes, we also said let's look outside of the Cleveland area and look at the Toronto area. So this slide here looks at other cities, and this is how the transfer learning can then be used to learn about another city based on data from a previous city. We then looked at the number of businesses by state. The reason we did this was to see the overall implication of how Yelp data could then be an agent to inform other cities on what they can learn from our economic model developed for Cleveland. Uh, this chart here shows a map of vegetarian restaurants in Toronto. Now, this could be any kind of restaurant. It could be high-end restaurants, low-end restaurants. We have several. We looked at many different kinds of maps and types of businesses. And this is where we have to spend some more time when we develop our final models because we want to figure out what most impactful businesses are for that locality. And this is going to take a lot of sifting through the data, which we will do in our next step. So these charts here show you the zip code level mapping from ACS and how we then overlaid that map with the ranking of each zip code based on the level of proximity of food available. Hidden in the orange, if you can notice, are little dots with the actual location of the restaurants. And these are pop-ups which the ranking will show different rankings for different zip codes. So we need to spend a lot more time in refining our maps and making our maps more interactive, as well as displayable in static format. So there is some amount of geospatial EDA work that we have to refine and clean for our next step. Uh, we then ran some predictive algorithms. These algorithms show how the maximum depth of the tree impacts the ability to predict. And we looked at a depth of around 3 to 4 trees, 3 to 4 levels seemed ideal and give us the best value of RMSE loss. We then looked at the overall pipeline, which we presented in our last checkpoint, but we have now implemented all of these aspects and understood the pre-processing steps required for geospatial joins from an implementation perspective and solved some of those features. We still have to do some feature selection. As mentioned previously, the geospatial data with 50 ACS features is a very large data set, but we have over 3,000 restaurants in the Cleveland area. So we have enough sample size to then accommodate these large features. And there are classifications within Yelp of the type of restaurant by let's say Mexican or Hawaiian. And we do have in the Yelp, in the ACS data, various minority populations. So we will refine our model, target, and to look at impacts on different populations by business. So there is some refinement in that area. We ran a number of models, naive Bayes model, decision tree model, random forest model, and the SVM model. Uh, we are yet to run INLA and other geospatial analytical models due to constraints of time. So, Vijay will talk a little bit about the XGBoost classifier model, the KNN classifier model, the random classifier model. What did you find, Vijay, when you took the Yelp data and ran these models? Which model performed the best?
Yeah, SVM is performing better compared to all the other models. That's because SVM, like the feature selection is not happening, and is as Professor said, SVM performs well on high dimensional data. So it's perfectly working with the text classification and text sentiment analysis and review related thing.
And when you ran the combined ACS data,
Yeah.
with these models, which model did you see perform well?
Both XGBoost and SVM performing like slightly better, but our SVM is outperforming the XGBoost model as well.
SVM is performing and with the geospatial data, I know you ran some initial models. We don't have it on the slide, but what was your take on adding the ACS and the geospatial data? What kind of algorithm, what was the results that you found? I know we've not put it in here because we're still finalizing it.
Yeah, initially when we added, it increased the dimensionality of the data.
Yes.
So we faced some issue while running the models. So we went with the decision tree and we
Group
did
them
some
by, yeah, we
yeah
looked at, and we're trying to look at space
yeah
between the data based on the geolocation and try
yeah
to kind of maybe do like a classification model
correct.
and group these restaurants separately by space dimension.
Yeah.
So that I think that may be something that has some implication. And our future plans, Babu, we are trying to now learn from one location
Yeah.
and apply to another
Currently,
location,
we
and we're looking
implement
at city,
across cities.
census tract, and zip.
Zip.
How are you creating the subsets from the spatial data?
Um, like
It,
you know,
the pandas data frames that you're
yeah.
reducing.
Actually, by using geodata frames, we populated our geospatial maps, and we try to implication on one city to another city, so that in future we are trying to implication this model for transfer learning to achieve multiple cities using the same model. These we are going to achieve in our future goals.
Excellent. So the we want to thank everybody very much for your time. And Hari, thank you.
Thank you.
Thank you.
Thank you.